Good morning, my name is Tomáš Košča. I'm a PhD student of Institute of Applied Mechanics in Slovak University of Technology, and I would like to introduce you our work about fatigue lifetime assessment of an additive manufactured bicycle. This work was a cooperation between our university and the University of West Bohemia. Bicycle does not seem to be an important structure, but the safety of a rider must be guaranteed. Fatigue lifetime assessment will be based on safe life approach. At the beginning, we have some loading parameters, material properties, and by using a fatigue accumulation hypothesis, we get a probability distribution of a failure. The parameters that influences the loading are total mass, driving style, road surface, structural design, and last but not least, a tire pressure. By considering and taking these parameters into account, we can build a spectrum for a specific type of bicycle in three ways. First is by using a simulation. Second is by using a combination of acceleration spectra and the simulation. And the third is a direct measurement by strain gauges. In this work, we choose a second method. The most common materials in bicycle frames are aluminum alloys and carbon composites. Aluminum alloys could be made conventionally or additively. Conventionally made materials have very good fatigue properties, but the fatigue properties decreases in welded joints. On the other side, additively made materials have no welded joints, but the internal defects lower the fatigue strength. Here are presented simulations of bicycle frames in 4 loading modes defined in Zedler test. The critical points are in welds where the fatigue properties decreases. Question is whether an additively manufactured material could overcome a low weld properties. Here is presented a world first additively manufactured bicycle. As you can see, the fatigue properties are changing with the printing direction. Vertically printed specimens have a slightly lower fatigue properties. Therefore, in calculations, we will always consider a worst case. On this slide, you can see the comparison of two heat treatments of a conventionally casted alloy. As I mentioned before, the critical points are in welds and these have a properties of T4. Therefore, we will further consider only T4 properties for a conventionally casted alloy. Here I would like to present a comparison between fatigue properties of a vertically printed specimens and the conventionally cast materials from FKM standards. On this slide, I would like to shortly demonstrate a measurement of loading by using accelerometers directly mounted on the bicycle frame. Presented data corresponds to a tire pressure of 24 psi. Data presented on this slide corresponds to a higher pressure of 45 psi. For a final comparison, Hague diagram was chosen, which relates a cyclic amplitude to a mean value. The graph shows a significant difference in cyclic properties. The marked points are showing the maximum allowable combinations of principal loading. The conclusion is that additive manufacturing significantly more reduces the fatigue properties of particular alloy compared to welding conventionally casted material. Thank you for your attention and I look forward to your questions.